Welcome to clickmyproject.com. Let we discuss about the process fast generation of virtual X-ray images for reconstruction of 3D anatomy. Let we see the abstract of the process. The segmentation of the image refers to extracting the needed regions from the images based on some specific methodologies. Segmentation methodologies are commonly based on thresholding, that is, the regions within the particular range or pixels that are having particular value. Edge detection, contour extraction, clustering are all common segmentation methodologies. Edge detection identifies the edge points around the needed objects. Contour extraction refers to outlining the segmented portion from the image. Clustering refers to the production of separate identifications, that is, color, contour differences for the regions in the image that are similar in intensity or similar in color. The clustering based methodologies segments the regions by grouping the pixels that have similarities in any of the cases such as intensity, color, etc. The clustering based methodologies groups the pixels that are having the similarities within them. The clustering methodologies can provide accurate results for most of the cases, as the number of clusters separated from the images which increases the segmentation accuracy of the process. The proposed FCM based segmentation method is clustering based segmentation methodology. The number of clusters were determined automatically. The images are initially pre-processed using median filter and adaptive histogram equalization. The median filter replaces the identified noisy pixels in the image by calculating the median of the neighboring pixels. The pre-processing step is the basic of all image processing process. This process makes the images to have same range of intensities in the whole image. Discrete wavelet transformations were applied to the images in order to make the clustering process robust to noises. The required regions are segmented from the pre-processed portions using FCM algorithm. Each pixels in the images were checked whether it satisfies the rules generated using the fuzzy logics. If the rules were satisfied, means the values were taken as the similar groups. The number of rules generated were default and they varies at different images. At each time the rule generation strategy changes in the FCM segmentation, the inverse transformation is applied to the input images and the clusters were obtained based on the generated rules. The image is segmented and the needed portions were identified. Finally, the performance of the segmentation process is measured. As the performance strategy, the accuracy of the proposed method is calculated. The calculated accuracy and other performance matrices shows that the accuracy of the proposed system is increased compared to the work in the existing methodologies, since the proposed FCM based method is an automatic clustering based methodology. Let me see the flow of the process. Input image is first subjected to wavelet decomposition. The wavelet decomposition splits the images into 4 coefficients, and these 4 coefficients were the image pixels of the original image. After that, inverse wavelet transformation is applied. As a result of the inverse wavelet transformation, the image with clearer regions compared to the input image is obtained. So as a result of this, we obtain the clear image from the input image. After that, kernel FCM is clustering is employed. In the kernel FCM clustering, the fuzzy C-means clustering is employed, which is combined with the kernel objectives, and the fuzzy C-means clustering identifies the similar intensities in the images and removes the unwanted pixels and group the pixels in order to identify different locations in the images. After kernel FCM clustering, the images were represented in different color representations, and each color representations denotes the image pixels that were all having similar intensities. So this process will be helpful in the clustering of the images, and also we can know about the different intensity regions in the images. The for each cluster, the cluster centers were obtained. Based on that, the thresholding operation is employed in order to extract the object portions alone in the images, eliminating the background processes. So after the extraction of the processes, 3D viewing of the input images is done. So the segmented portions were alone denoted in 3D viewing in order to view the images in 3D locations. So as this process is helpful in the 3D viewing of input images, which is employed based on kernel based fuzzy C-means methodologies. For that, the input images were initially enhanced based on the wavelet transformations that were all applied using discrete wavelet transform. The 3D viewing of the images will be more helpful in the further researches of the analysis and the registration of the medical shapes. Let me see the running procedure of the process. If you want to run the code, select the file demo.m, which is located in the source code folder. Right click it and click on run file. You will get the user interfaces and the process will get started. First select any one of the images which is present here. We can use any one of the images present here. So first the input images were taken and they were pre-processed. After that, the images were decomposed using discrete wavelet transformation, and the clustering processes is employed using kernel fuzzy C-means, and the extracted clusters were got as shown in the display. So after this final cluster is done, this is the readability applied image, and this is the clustered result in each of the color channels that we have given, and this is the final cluster that we have obtained, and finally this is the detected regions in the images. This detected regions is the viewing is helpful in the viewing of the 3D locations of the images. Thus we have segmented segmented the objects in the images, and we have displayed it in 3D viewing based on the clustering employed using kernel based fuzzy C-means. So this process is applied for color images. So for any type of color images, this process can be employed.